In this video, we will be looking at the binary search algorithm with a focus on a description of how the algorithm works. So let's look at step 1, choosing the middle element within a list. In this first list, you can see that we have an odd number of elements. Therefore, that gives us an even number of elements on each side of the midpoint. A relatively straightforward process. When you have an even number of elements within a list, the midpoint is not so clear. In this case, we have 3 on the left, 4 on the right, or if we choose parrot, we have 4 on the left and 3 on the right. And it's up to the programmer to define which one of those they use. I have detailed this in the purple text, although a pupil studying at GCSE level would not be expected to detail points A and B. All they need to be aware of is the choice of a mid-element, the middle element within a list. Step 2 is checking for a match. Now, what I have found is that many pupils miss this stage out and lose marks. So this is why I've put this in red ink. I think it's very important that we look for trends of weaknesses in student attempts in examination questions. So let's do a worked example looking at where we're finding a match straight away. So we're going to try to find parrot straight away. So we find the midpoint. Parrot is the midpoint. Step 2, we found our match. And it's very important at this point that the pupil realizes the algorithm would then stop. It would be inefficient to keep searching for an element that it has already found. So the algorithm would stop. If this if statement is false, we obviously need to determine whether we go to the right of the list or to the left of the list. So let's take the situation we're searching for a tent. So tent is here in the list. So we start with our midpoint, which is step 1, and we have parrot. And we'll notice that the thing that we are looking for, tent, is greater than parrot. So therefore, we ignore, not delete. A lot of pupils make that mistake by saying we delete it or we're not. We're going to ignore this side of the list. And we're going to focus on this side of the list. If we were searching for mouse, again, we start with parrot and we say the thing we are looking for is mouse, that is less than or to the left of parrot. So therefore, we will ignore to the right side of the list, including parrot. So if we look at our if statements, our first if statement will look for a match. If this is false, it will search for an element to the right of the list, which is greater than. If this is false, we are going to look to the left of the list, which is less than. Once this is done, we would jump back to step 1 and continue our process of searching until we find an element is either found or the element is not found. And in this case, this could be seen as having a list of size of 1. So let's take, in this example, we're going to search for rhino. So we're going to use rhino as an example. Remember, this question though is asking for a description. So we've covered our description. This worked example now will be just to see how we can find rhino within our list. So step 1, choose our midpoint, which is parrot. The data we are looking for is to the right of parrot. Therefore, we will ignore parrot and elements to the left. And we are now going back up and choosing our new midpoint. So our new midpoint could either be tent or wall. Remember, there isn't an exact midpoint, so we will choose tent. And step 2, check for a match. We've found our match. therefore the algorithm would stop. There will be further videos demonstrating the use of a binary search following this description video.